Hello, everybody. Welcome, Harry and Gabe. Let's check your mics before we kick off, shall we?
Yep. Good to be here. Harry Grieve, CTO, co-founder of Gensyn.
Hey, pleasure to speak with you all again. Name's Gabriel, researcher.
Fantastic. Thanks, guys. As always, to everybody out there, welcome and thank you for coming along. Today we've got, as you heard, Harry Grieve and Gabe, who we have heard from a few times before. Quite recently, went through with Gabe on the topic of what is a prediction market. So today's conversation is going to follow along quite nicely. And not taking up any further time, I think I'll just hand it straight over to the two of you. Harry, do you want to kick us off?
Sure. So to give that framing around prediction markets and how they relate to what we're building at Gensyn. So at Gensyn, we're building the network for machine intelligence. It networks together resources required for AI systems to scale. So that can be like data, compute, more broadly, just signals from out in the wider world. And we think prediction markets are a very good kind of initial use case for models which are autonomous in that fashion, particularly because it shows models performing actions, out in the world. Number one, but number two, it provides a kind of market for machine intelligence in many ways as well. With that in mind, last year, many of you will know we started shipping Delphi, so that's our kind of live prediction market. It uses an LMSR, and then before that, we also experimented with more kind of simple markets with our Judge release, which was around Q3. We're in an interesting spot just now where internally we've been looking at the different ways in which you can essentially provide a market system for providing prices on various future outcomes. And what's nice is obviously machine learning systems can settle those markets. They can determine what the correct outcome is. And really that kind of led us to discussions internally around the LMSR, which we're currently using in Delphi, and it's on the Jensen mainnet, sorry, on the Jensen testnet, and then also parimutuels, and then sometimes some kind of hybrid solutions as well, which sit between the two. And there's a bunch of trade-offs. What I think would be good for the community is basically if we walk you through some of our thinking on it, and then take questions on these different models, and also how other kind of companies in the space, so for example, like Polymarket or Kalshi, how they approach these problems as well, and what systems they use in order to provide prices on future events. I'll pause there. I don't know if you'd add anything to that, Gabe, just before we get started.
No, that pretty much hit the nail on the head. You even caught the hybrid in between part that I was probably going to fill in. So yeah.
Perfect. Well, I think as you guys know, Gabe on our team has been spearheading a lot of the research on these topics, and has been doing a really solid job. So maybe do you just for the, I know some people here maybe don't even know what an LMSR is or a parimutuel is. Do you want to just maybe give a quick like flyover? What are these two kind of solutions, and kind of how do they relate to other solutions used by, say, Polymarket or Kalshi?
Totally. Yeah. So uh, broadly, you can think of these things as living on a spectrum between pure prediction, like automated market makers, and sort of like wagering mechanisms, right? So LMSR is probably the purest prediction market automated market maker, where someone had the market creator is looking to, and these are for what's called information aggregation. I should preface with that as well, right? So the idea is you want to aggregate information from many sources when you design these mechanisms, and then you have assumptions about why you want to do this, etc. In LMSR, you make the assumption that somebody wants to find out some truth. They basically put up some liquidity, and that liquidity is used by others to execute trades at any point. They don't need a counterparty. If the price is at point 0.5, you think your belief about an outcome is point 0.6, then it makes sense for you to buy it at point 0.5, because when the market settles, that share that you bought on that claim is in expectation to you going to pay out one, right? So you're going to make profit on that. Now, if on the other side of this, you have things like parimutuel that are what are called wagering mechanisms, so to speak, but they're also for information aggregation. Parimutuel is commonly used in a lot of systems like horse racing, wagers amongst friends, things like that, where essentially you don't need to put up liquidity. The idea is I want to aggregate information, but I don't want to put up liquidity necessarily to pay for that information. So the market needs to provide liquidity for itself. So what happens here is that if there's two positions, for example, yes, no, and the outcome ends up being yes, then the people who bought no pay the people who bought yes. There's pros and cons to both. LMSR, for example, you don't need to worry about what the no people who believes no. In Parimutuel, if no one believes no, it's very obvious, like, will the sun rise tomorrow? Then my payout for saying yes is very little, right? Very few people put money in the pot that's going to pay me. And I need to split it with everybody else who went in the yes direction. By comparison, places like Polymarket, Kalshi, etc., they use a an order book. Specifically, it's a central limit order book, so it's very centralized too. So there's other we have qualms there as well. I think Harry would mirror that on the centralization element there. And yeah, the big difference there is they basically have no like they don't to provide liquidity in those systems, like the system isn't self-sufficient. It requires external market makers to come and put in money to make liquidity. You might ask yourself, why would they do this? It's because they're probably going to make money doing so. And there's lots of ways to do that. That's a whole topic on itself. Hedge funds exist for a reason, and they do quite well for themselves, right? But yeah, so they're using central limit order books. There's a post that I just wrote at length about the topic, so I won't go too much into it. But these systems are not kind of self-contained. They're really hard to decentralize, and yeah, you need to find a counterparty. You can't just put your belief in. You need to put a belief and have someone who has the opposite belief in some sense for them to
Yep.
work. But
Yep.
yeah.
Perfect. So yeah, so essentially you can kind of, if you think about it like a decision tree, you can kind of go centralized or decentralized. On the centralized pathway, you immediately kind of enter the sort of order book world, which kind of a poly market would exist in with central limit order books. In a decentralized world, it's quite difficult to do an order book on chain. So you typically end up in a kind of LMSR style configuration, which is not dissimilar, but not the same as a kind of AMM. And then you have parimutuel approaches as well, and they can kind of work in either setting. I think when we've been thinking about like what we prioritize for, there's really kind of like four things. One is we're pro decentralization. So we think that decentralizing technology is a force for good in the world. It enables fairness, enables transparency, and that also, and incidentally promotes actual price discovery too, because it's more of a free market. So we care about that. We also care about ease of use. So just kind of intuitively, like if you're using one of these systems, like how easy is it to use? Does it actually make sense to a kind of demand side user? And then thirdly, if you're creating one of these markets, how complex is it to, or how much friction is there to setting it up? So one of the issues, for example, of LMSRs is you typically have to, as Gabe alluded to, you have to put liquidity behind the LMSR, which for someone creating one can actually be a pretty kind of negative situation. And finally, I'd say the fourth point is just around volatility. Like, is there a kind of, are there systems where the price is just much more volatile versus another one? And if it is indeed volatile, like how much does that degrade kind of overall user experience? So those are the kind of, I say like four like big kind of things we go through on it. One of them is a little bit more philosophical, the kind of first one around decentralization, and the second, third, and fourth are more kind of practical. What would be interesting, I guess, Gabe, is while we look at our current like decisioning internally of we have this LMSR technology, we have parimutuel technology that we're kind of looking at as well. What would you say the kind of obvious trade-offs for someone maybe thinking I'm going to deploy one of these things on the Gensyn network? What would you say like the kind of key trade-offs would be if they're trying to do a prediction market and it's being settled by a model?
Yeah. One, I mean, there's a few things that come up. One is, like you said, the complexity is a big one, right? Between the two. If I want to do a pairing mutual, I just go, hey, I have a question. Here are the outcomes that are possible. The model's going to decide one. let it rip. I don't need to figure out this like parameter B. Like honestly, like Harry was saying, the complexity on LMSR setting B, it's like it's got its own set of papers on it, right? Like people have written and made entire PhDs on how to set B.
Could you
So
could
it's
you could you explain B to the kind of least knowledgeable person in this room just now? If you had to kind of assume that, if you, like, yeah, how would you describe it to someone who has no context on LMSR mathematics?
Yeah, it's that's a tall order. But the short of it is that like these LMSRs fall into the family of like these AMM prediction markets. These are these all root from one thing that's called a cost function, right? LMSR uses the logarithmic market scoring rule cost function, but there's a whole family of these cost functions. The price in the LMSR market is just you get it from the cost function. Everything is driven by that cost function at the end of the day in LMSR. B is in some sense deciding the curvature of that cost function in that logarithmic market scoring rule. I know that means nothing, but the short of it is that it becomes if I make a trade for $100, how much does that move the price? Right. So for if the odds right now are zero point 0.5, I put $100 in and B is tiny, I'm gonna shoot the price right up to 0.99999, whatever the precision is. And basically any trade if B is too small, any trade will just fly the prices all over the place. It can't stabilize. If B is too high, then it can't move either, right? And at the same time, the market maker is at the on the hook for a big loss if in the worst case, because B decides how much you move the price is because the market maker is the one who's giving you the ability. The market maker is basically saying, look, I put up this B. That means that you having the ability to move the price in very precise amounts is me being able to pay you that amount as well. Um, was there another part of that question? But yeah, I think that's the gist of it.
Got it. I think one, just to kind of riff on that, an additional kind of issue that we see is when you're creating a market which is an LMSR, you can do kind of positional trading. So you can, similar to kind of poly market, you can like buy and sell your position, which is obviously attractive to people, if they want to kind of get in and get out, depending on how oversold or overbought a given probability is. Um, but I think, a second kind of interesting piece about the parimutuel is basically in a normal parimutuel setting, where essentially two people, in the simplest terms, two people are making a bet on something. Um, because the kind of final odds which you get are calculated right at the end, you actually aren't incentivized to kind of bet early. So to give you an example, if you're betting on a boxing match and the question is which boxer will win, and there's obviously two options. If you want to do one option or another option, and there's a few people betting on the market, if you bet early, you're going to get the same price essentially as the final person who bets in the parimutuel. Therefore, you have no incentive to kind of bet early and provide that kind of signal as to your intentions. Now, this is solved in parimutuels by basically having a system whereby they close betting. Before the boxing match might start, which means that everyone gets the same price, but there's no kind of live information which is affecting any of the early betters. So whilst people might not bet up front necessarily, they aren't disincentivized to. When you think about that, Gabe, um, do you see any solutions to it, like in the context of a prediction market? So say we're doing a prediction market on a real world event,
Mhm.
how would a parimutuel kind of be made appropriate in that setting, given that there's this kind of timing issue where people aren't incentivized to kind of place bets early?
Yeah, so there's a few layers to this, right? So in general, pari-mutual struggles with this. It's a bit fundamental in pari-mutual, but pari-mutual has also led to its whole family of related wagering mechanisms that solve this precise problem. There is other ways to kind of solve it without changing pari-mutual though, and it really depends on the question being asked, etc. But like one example of it is, what if the market can settle at any time between now and a week from now, right? Something like when when will I don't know. When will it rain where I live, for example, right? It's likely to happen eventually. We can keep it open ended. We don't know when it'll settle, but as soon as it settles, like you can't put your bid in. So you have this pressure just from the fact that like you know the event will happen. I don't know when it will happen. And this actually is a question that might be interesting for you. I don't know if you've thought about this much, Harry, but we can with AI and machine learning as the settlement formalism. It's a bit hard to formalize. We need to think about it a bit deeper, right? There's definitely edge cases. Couldn't we could also like do this in a sense of like we can use latency and like the token generation length, things like that, convergence time on models as an artificial way of essentially creating that barrier and that pressure. You don't know when it'll converge. You don't know when it'll finish generating its tokens, its full token length. But like, get in there because it might do it at any point. What do you think about that as a solution to this sort of thing?
Yeah, I agree with that. I think it is an interesting solution. Um, I do feel like one of I feel like there isn't like a kind of classical way to solve for it without one of these kind of like more novel approaches. Other than simply like freezing the market early, there have been like examples I've heard of people saying, well, maybe you can kind of provide a extra reward for people who like place bids early. And there's a version of this on Polymarket where longer term markets are you're incentivized to kind of bet in them and trade in them just to provide liquidity. You get like an extra bonus reward, which could be like a way to also solve it more mechanically. But I do agree that the kind of more like machine approach is appealing. Cool. So we're about 20 minutes into to this space. I want to kind of make this relatively like interactive. So I don't know, Xavier, are there any questions or any like community questions or anything that you recommend we cover?
Let's see, nothing in the tweet thread as yet. A couple of people have requested to pop up on stage if you want to allow those, or do you want to wait to the end for anyone to come up live?
Yeah, we can allow them. Let's have whoever did first. We can do a couple.
Very good. Let's go with Inco. Just a reminder to everyone we bring up, if you can make sure to keep the questions on the current topics, that'd be marvellous. And Inksaw should be coming up shortly.
Cool.
Inksaw, welcome.
Hey, yeah, doing well. How are you?
Good. You.
Talk about compromise wallet. I think you guys are aware about how many users are affected by hacking wallets, right? Do you guys hear me?
I can't hear you. I didn't quite get the question though. Would you mind just maybe saying it slowly?
Actually, I am talking about wallet compromise. Recently, many users
Okay.
complained about it. We got
Inksaw,
hacked.
I'm
Our
happy
wallet got
to
hacked.
follow that up with you in the Discord a bit later on.
Oh, cool. Right. Yeah. So that was with respect to the sale. Yeah. Xavier can follow up with you in the Discord on that one in Xcore. Thank you for flagging it though.
Let's try.
Yeah.
We've
Go
got
ahead, Xavier.
one more request if you want to try Hamad.
Yep.
Actually, I want to know when we will get an update about that compromise wallet.
Hamad, welcome. Hamad, can you hear us? Nope. Looks like we might just carry on for a little while, Harry.
Perfect. Cool. So yeah, maybe if we put Hamid back to listener then. Perfect. Thank you. Cool. So we've kind of covered a few topics here. One is the sort of nature of parimutuel versus LMSR, like mechanically. Two is the broader kind of space of options that exist like in the market. And then thirdly, are some ways to kind of make parimutuels more more kind of applicable to the kind of use cases we have. I think there's like an interesting like fourth thing we can talk about, Gabriel, which is there's that kind of dynamic LMSR versus this kind of fusion of the two technologies, which we've spoken about internally. Do you want to maybe give some context on that, and then how you think that that could also be like an interesting kind of system for solving these issues?
Yeah, so there's so people basically looked at this dichotomy. I guess to give it, I think it's also helpful to do a quick preface. I think I touched on this, but I didn't quite say it explicitly earlier, which is when you think about these information aggregation mechanisms through markets, et cetera, you have to make the assumption of does the person want to put up liquidity or not, and then there's also the assumption that and then this like leads you down a few branches. One is this wagering, where the idea is like what are you aggregating, et cetera? What do the prices mean? The other one is the AMMs. You start going down this whole like rabbit hole of things. People looked at both, said it'd be nice to be able to kind of achieve both. No liquidity needed, yet still able to aggregate information. Prices, you can buy and sell positions. You aren't locked in like you would in a vanilla pari-mutuel, yada, yada, yada. There was actually like a result. I'm not going to keep going on this. I'll talk for an hour on this negative results. That's really elegant in my opinion. But it basically says you can't have three things. One, you can't have prices that mean a very interpretable thing. You can't have so basically like pick two out of three prices that are interpretable in a very concrete way. No need for liquidity, and how would I frame this last one? No need for liquidity and buy and sell positions, right? So like two-way flow. Turns out you can't have all three at once. It's usually pick two unless you want to do ridiculous things having to do with like randomness. People looked at this, studied this for a while, and what they found like in 2007 just about was something called dynamic pari-mutuel, which is another cost function market maker. It's related to LMSR, but the price that comes out is all about the share ratios between the two between two or more positions. This makes strategy quite hard, but I think it's quite nice. It solves a lot of the problems with LMSR, solves a lot of the problems with pari-mutuel. Yeah, and it's quite elegant. It's quite simple, honestly, to formalize. The only downside to it is that it doesn't fully solve all the problems. It kind of inherits problems from both. But in practice, I think it's quite negligible. It's things like you can pump up the price on one and then sell when people join later, right? That you can kind of do that with pari-mutuel anyway if you're not careful. But anyway, yeah, just throwing that out there. Then there's other things that kind of spun off from this to solve the existence of all these problems, which is a whole class of scoring rule wagering mechanisms, but a topic for another day.
If someone, so if let's say I was someone in this chat and I've kind of been listening along with the LMSR, the kind of study you did on the LMSRs, I kind of broadly understand pari-mutuel, and I have a background in kind of, I understand AMMs conceptually. How would you, through the lens of someone who's maybe more from like the AMM camp, where they understand how those work quite deeply, how would you describe the dynamic LMSR through that lens? I think yesterday you kind of, maybe it was a little bit like reductive, but you described it sort of like it can be like a kind of LMSR, it can be like a kind of AMM of pari-mutuel bets. And that's the some like one like perhaps broken mental model for it. But it'd be interesting to explore it through that lens, I think.
Totally. Yeah, that's actually what a lot of these AMM prediction markets are at their core. If you look back at like the original paper by Hansen, they're looking at these market scoring rules that are meant for like one-shot events. And the thought experiment is basically, what if you had these happen infinitely often, in like one after the other? All of a sudden, you unlock like what was one shot buy sells. You unlock this very elegant thing, which is LMSR. They did a similar thing with pari-mutuel. What if you had infinite pari-mutuels happening back to back to back to back? And you can think of like a version where you like can put like a sell order on the pari-mutuel. That's how you get the dynamic pari-mutuel to come out. And that's also how they're related. If you do just the buy version, it's also becomes a mechanism, right? It's just a bit weird to think about that way. Is that what you're referring to?
Yeah, it is. And then from a liquidity perspective, is that the same as an LMSR?
No, technically it has infinite liquidity, right? Dynamic pari-mutuel and pari-mutuel both have infinite liquidity. The reason that's not in the sense of like, It's tricky because I think liquidity is an overloaded term. In AMMs, it's overloaded in finance in general. But yeah, basically, they have infinite liquidity in the sense that like you can move prices indefinitely. You don't, no one's backing it. So if you keep believing in one direction, you could, in theory, keep bringing the price up in pari-mutuel. Similarly, in dynamic pari-mutuel, it'll go on forever. And so it differs a lot from LMSR, where it has a fundamental bottleneck that controls volatility, volume, etc.
Got it. Clear. Clear. Yeah. And then as a final question for me on this, there's an ability in some systems. So I think, for example, there's if you read like some white papers of people who have also done decentralized LMSRs or even just like the dynamic LMSRs, they'll talk about people adding liquidity for basically buying a basket of options, or no, well, not options, but buying a basket of outcomes, to use the right terminology.
Hmm.
And that's a way, like if they, symmetrically buy, or not symmetrically, but if they equally buy such that if something's priced at 60% probability to buy, and you have $100, they'll buy $60 of that and then $40 of the other thing. That kind of injects liquidity into the LMSR, and it has an effect of kind of making the prices less volatile. Um, is that like a broadly true conclusion that that's a way to add liquidity? In other words, you could just be someone who's like, I'm going to bet equally across everything, and sans the trading fee, this is going to add liquidity to the market.
I think it's an oversimplification, but yes,
Yeah,
that is actually like one of the way you reduce actually to AMMs bringing that. I think I forgot to mention the AMM part of that question that you asked. That's actually how you map it back to AMMs.
yeah,
You can think of it as basically like a full bundle is $1, right? At the end of the day, if one of those things is going to be true, therefore, if I buy one of everything, I paid $1 in total. And yeah, that's how you relate to AMMs because then you can exchange that for individual assets essentially, and that's the exchange that you're doing between goods. To tie it into the liquidity in the AMS and LMSR, though, that is an oversimplification because it's hard to describe. It's very geometric in nature. Like that B, like I said, is the curvature of a cost function. If I'm buying a bundle at some part of that curve, it's not the same as buying that bundle somewhere else. Really, it's like a promise to buy the bundle is what it should be.
right,
I don't think that that'll work at scale, is kind of what I'm trying to say. It might be a patch, it might look like it for now, but when you start stress testing, it almost certainly will not work, and there will probably be some solvency problem or
right.
some early stopping with precisions. There's going to be something that's going to give.
Got it. Clear.
Yeah. Um, yeah, I think there's a lot of hacky things people are trying to do, but to solve these problems. But the reality is it's pretty fundamental, and it's quite deep. So I think people want to give a easy solution to a difficult problem, but it is just fundamentally a difficult one. Um, try to make your car fly type of thing, right? You don't just put some wings on it and hope for the best.
I'm sure you could if you tried, Gabe. As we head towards wrapping up, I actually just wanted to jump in and ask, and Gabe, feel free to jump in at any point. I know this directly affects your area as well. You went into some detail last time on other research you've been doing that ties into today's topics. But Harry, since we've got you with us, can you go into a bit more detail on how Parimutuel's LMSR fits directly into Gensyn's engineering group and engineering efforts?
Happy to, yeah. So when we work on LMSRs and implement a lot of the research that Gabe's been describing here, it mainly sits inside our smart contract team, and I would describe that as kind of one of the kind of core like functional areas inside our technical team. It almost, I mean, essentially all the code is on chain. There's obviously ways you relate to it, and you can kind of place bids and stuff off chain, and how we do that in the apps sits elsewhere. But it's essentially like the majority of the kind of on chain work we've been doing for the last couple of months. The and obviously all that technology needs to be audited, and working with auditors to kind of get that closed out as well as a kind of relatively long process. But there's probably about four other kind of edges to the Gensyn technical function, which we've been working on over the last few years. The first is reproducibility. So for those who don't know, reproducibility is basically the process of running a graph of compute operations on different devices and arriving at bitwise exact results. So, and on the same device, you call it determinism, but reproducible between devices, and that's important if you're interested in doing machine learning based settlement, because it allows you to kind of arrive at truth. So, for example, if a model settles a market in one way, and it says, the answer is, that the answer is that Mike Tyson won this boxing fight, for example. That produces those tokens, which machine learning tokens, I should say, which produce the kind of output. They're hashed, and if you can kind of commit to those that output, and someone else can reproduce it elsewhere, that produces trust in the process, which of course is important when you're using digital money. So reproducibility matters a lot there, but there's a few other areas of the team. So we also focus on the kind of more like full stack. Also kind of front end leading application development. So if you've ever used a Delphi app, which is currently on testnet, you'll see that it's relatively slick user experience. It's kind of optimized for mobile, etc. as well. All that kind of sits inside our full stack team. We also do a lot of work infrastructurally. So we with the researchers, we run various experiments. We have papers being submitted to kind of major machine learning conferences this year. All of that requires us to kind of run our own GPUs, and that takes enormous kind of infrastructural kind of energy. The final thing I'd say is just on the machine learning side. So we do a kind of hybrid between sort of more like experimental machine learning engineering, where somebody might be working with machine learning research for distributed training systems like RL Swarm, and implementing those, all the way through to the more kind of like, I guess, machine learning engineer facing kind of SDKs which are required. So, for example, with our reproducibility technology, putting that into a runtime which can be used, imported into a kind of Pythonic workflow and used accordingly. So those are the kind of four areas. We have the kind of smart contract side, which is obviously completely on chain. Typically deals with things like the markets we're discussing. We also have the compiler and kind of rep-op, sort of reproducibility element, which focuses on achieving those kind of consistent outputs between different devices. We have the infrastructural side as well, focused on kind of this sort of ancillary support and powering all the other teams. And then finally, we have that machine learning team, which can be at once both experimental and product orientated. So that's the kind of quick flyover of the kind of internal engineering landscape here. I don't know. I hope that answers the question, Xavier.
Absolutely. And what I've found brilliant across several of these spaces is that whether it's you, whether it's Gabe, whether it's Dio, little pieces of each thing that all of you are describing about this entire ecosystem are all fitting really, really nicely together, but also with the theory that each one of you are putting forward. One little follow-up to the engineering side of the question. In your opinion, what areas, whether it's theory or technology or techniques, do you think Gensyn has pushed furthest forward?
I mean, definitely on the reproducibility side, I would say is number one. It's also the thing that we've been doing the longest, I think. So maybe that could be more of a kind of reflection just on the kind of on the amount of time we've spent on it. But certainly that, I think, a close kind of second is on the is on some of this on-chain kind of to market stuff. So the LMSR that we have implemented on testnet, it does have a lot of kind of nice. I guess I wouldn't maybe go as far to call them like safety or security features, but quality of life features, which basically make the entire like process of using it just substantially less less like unstable. I think one of the big issues you have with things like LMSRs, as Gabe can attest to, is whenever you're dealing with exponents and very large numbers, you end up having lots of issues when you're representing them in outside of floating points, and obviously chains don't support floating points natively. So kind of dealing with precision and precision losses and things like that just in the EBM can be pretty hairy. And yeah, we've done a lot of kind of great work there, in my opinion, as a team. So I'd say, yeah, as a close second, it'd be some of that work on the chain. But yeah, it's a little bit back. Like the reproducibility stack is probably the one that's the most kind of mature.
Fantastic. Thank you, Harry. Gabe, any comments to add?
No, 100%. And I think that with time, we're seeing a lot of nascent prediction market sort of things. People will see the reproducibility really come to the front when your oracles come into question. I mean, we have all the controversy in poly market, but we'll see. That's my wager personally.
Marvelous. Well, thank you both so much for taking the time out of what I know are very, very, very busy days to come and speak to us. Thank you, everybody out there, for coming along and listening once again. Harry and Gabe, if you've got any closing remarks or any particular thoughts that you'd love people to leave with, please go ahead now.
Yeah, nothing from my side other than just a big thank you to the kind of community for joining the session, and also for all the people who've been using the kind of Delphi app on testnet currently. We're currently going over a review of the app and its kind of suitability for mainnet, and also the kind of broader, as we've been talking about on this call, like the actual market system for it, and which one makes the most the most kind of sense for us, just from like a UX perspective. Frankly, there's different, as we've talked about here, there's different flavors of market system, LMSR, Parimutuel, and they both have different shapes when it comes to user experience, and we just want to make sure that it's the best experience for everyone. So yeah, that's it from my side.
Yeah, I just want to say thanks to everyone for coming, and thank you to Harry also for working tirelessly to. I can vouch for it. Working tirelessly to make it all make sense and be the good experience for everyone and work. So yeah, thanks everyone.
Fantastic.
Brilliant.
Cheers.
Thanks again, guys. Lots of exciting things coming down the line. And thank you all again for coming along. We'll be back on Friday with Mark's Zhang. You can find the event in Discord. And look forward to seeing you all again. You all again then.